Okay, we're going to be talking about the properties of special quadrilaterals. What we want to be able to answer at the end of this is how we are going to use those properties of quadrilaterals to specifically identify them. So first things first, we need to review the slope formula and distance formula. If you don't know those, make sure you write those down real quick so we can reference those a little bit later on. Also, make sure you have out your worksheet on the flowchart of quadrilaterals. Today we are going to be specifically looking at parallelograms, and then if we can further classify those into rectangle, rhombus, or a square based on the other properties that those three quadrilaterals possess. So the problem that we are going to be looking at here is asking us to determine the most specific type of quadrilateral formed and explain our reasoning given these 4 points, which I've already graphed here for us. Now remember, we cannot assume anything about the angles or the lengths of the sides until we prove it. So we need to use those two formulas to do so. So let's start first by finding the slope of each one of these sides. So let's find the slope of xw first. That is up to over 4, which simplifies to 1/2. The slope of yz is also 1/2 when it is simplified. Then let's look at the slope of yx. That's up 4 over 2, which simplifies to 2. And then the slope of zw is also 2 when it is simplified. So from that information there, we know that xw, segment xw, is parallel to segment yz, and segment yx is also parallel to segment zw. Now this should make sense since earlier I was telling you we are going to be dealing specifically with parallelograms. So now that we have that information, let's look at the lengths of each one of these segments. So the length of xw is the square root of 2 minus a negative 2 squared plus 3 minus 1 squared. Now, when you have minus a negative, make sure you put plus a positive. That simplifies there to the square root of 20. Now let's look at the length of yz. We have the square root of 0 minus a negative 4 squared plus negative 1 minus a negative 3 squared. This also simplifies to the square root of 20. Now we could simplify the square root of 20, but since we're just looking for the length and that is the same radical there, we don't have to go any further. Now let's look at yx. We have negative 2 minus a negative 4 squared plus 1 minus a negative 3 squared. Again, we get the square root of 20. And then lastly, let's look at zw. So there we have the square root of 2 minus 0 squared plus 3 minus a negative 1 squared, which also gives us the square root of 20. So now from there we can say that xw is congruent to yz, is congruent to yx, is congruent to zw. So now we want to identify this most specific type of quadrilateral that we were given. So if we go back to our flowchart, we are looking at these three here. Now, if you recall, when we were looking at slope, we had the slope of 1/2 and 2. Now, in order for us to be given a rectangle here, all angles had to be right angles. So since those slopes were not opposite reciprocals, we cannot be dealing with a rectangle. So now we're looking at rhombus. Now, for a rhombus, this first characteristic, this first property here, is that all sides are congruent, which is ultimately what we proved there at the end when we found the length. So these 4 points here give us a rhombus because of the slope and lengths of the sides that we proved.